Hey everyone, welcome to The Explainer. We literally use computers for everything we do, right? But how often do we actually stop and think about how they work from the ground up? Today, we're going totally back to basics. We're going to break down the anatomy of a digital brain into simple building block concepts. By the end of this, you'll have a rock-solid grasp of exactly what's going on beneath that screen.
But before we get into the nuts and bolts, I've got a quick question for you. Do you know who the father of the device you're watching this on actually is? Seriously, take a brief pause and think about it. Someone had to dream up this incredible tech sitting right in front of you. Any guesses?
Okay, here is our roadmap for today. First, we'll meet the computer. Second, we'll look at the 4 types of computers. Third, we'll ask, what is hardware? And finally, we'll dive into input and output devices. Section 1. Meet the computer. Let's define exactly what this machine is and where it all began.
So, the answer to our opening question? It's Charles Babbage. He is widely known as the inventor and the absolute father of the computer. It's kind of wild to think that the sleek little devices we carry around in our pockets today actually share a direct lineage with the concepts he mapped out way back when.
So what exactly is this machine? At its core, a computer is an electronic device that manipulates information, or data. But the absolute magic here is the loop. It gives you an output based entirely on the data you provide as an input. You put data in, the machine manipulates it, and it spits a result back out. Literally everything a computer does, from running a massive video game to just calculating a spreadsheet, boils down to that one simple loop.
And to actually pull off that manipulation, there's one foundational rule. Computers work based on a link between hardware and software. You literally cannot have one without the other. They are two halves of the exact same whole. The physical machinery needs the invisible instructions, and those invisible instructions, well, they need the physical machinery to actually run.
Moving on to Section 2. The 4 types of computers.
Now, while that core input-output loop stays exactly the same, the machines themselves scale up and down based on what we need them to do. Generally, they fall into 4 categories. First up is the personal computer, the one sitting in an office, a school, or your house. Next is the mini-computer, which is often used for specialized drawing purposes. Then, we scale up big time to the mainframe computer. These are the absolute powerhouses sitting inside banks or IT companies, handling massive amounts of daily data. And finally, the supercomputer, which is built for incredibly complex scientific calculations. So, from a house to a high-tech lab, the core concept remains, but the sheer power shifts dramatically. All right, Section 3. What is hardware? Let's talk about the physical reality of these machines.
If you've ever felt intimidated or bogged down by computer jargon, the definition of hardware is wonderfully simple. It is literally just the components of the computer that we can touch and see. That's it. If it occupies physical space, if you can knock on it with your knuckles or look at it with your own eyes, it is hardware. It's the totally tangible half of that hardware-software link.
And to keep things organized, hardware breaks down into 4 distinct categories. Number 1, input devices. Number 2, output devices. Number 3, processing devices. And number 4, storage devices. That basically covers the entire journey, from where data enters to where it gets crunched, where it lives, and where it exits. Now, for the rest of this explainer, we're going to zoom in really tight on just those first 2 steps. Which brings us to Section 4, input and output devices.
This is really where the rubber meets the road, how you and I actually interact with these incredible machines every single day. It helps to conceptually separate the flow of information here like a two-way street. On one side, you have input devices. These are designed specifically to send information to the computer. You are pushing data into that digital brain. On the flip side are output devices. These produce or display information from the computer back to the user. So input pushes in and output pulls out.
Let's hit some rapid-fire, everyday examples of input devices. We're talking the keyboard, the scanner, the camera, and the mouse. Think about it for a second. The very mouse or keyboard you might have your hand on right now, or even the touchscreen of your phone, those are input devices. Every single time you click, tap, or type, you are sending a discrete piece of information directly into the computer's processing loop. You're giving it the exact data it needs to start working. And then, once the computer has done all its manipulation behind the scenes, we actually need to see the result, right? That's where our output devices come in. The monitor, the speaker, the headphone, and the printer. And again, you are experiencing this right at this exact moment. The monitor or screen you're watching, the speakers or headphones you're listening to my voice through, these are actively outputting the results of this explainer straight to your senses. The machine is displaying its data right back to you.
So we've successfully broken down the digital brain. We know the fundamental loop is taking input, manipulating it, and creating output, all made possible by physical hardware. But I want to leave you with one final, kind of mind-bending thought to ponder. If hardware is purely what we touch and see, and a computer only works based on a link to software, how does that invisible, completely untouchable code shape the physical world you interact with every single day? It's something to think about. Thank you so much for joining me on this explainer, and keep exploring the incredible tech right at your fingertips.